So in physics, we have a concept called dampening. Dampening is going to be the idea that an object that is being oscillated could lose energy at different rates throughout the oscillation or through different forms of an oscillation. So if I have a car driving down the road, the best way to think about this, one of the best ways to think about this is a car driving down the road and it hits a pothole. Okay, hits a hole in the ground, and so the car starts to oscillate up and down, up and down, up and down. If the car hits the hole and there are no springs on the car, the wheel will go down. It'll be a very sharp bump, and the car's axles and the tire, for example, could be damaged. So what we do is we put on there a spring, and they come in a variety of shapes and sizes and types, depending on the vehicle and the design. These shock absorbers that are on your car help absorb energy. And their objective of these devices is to allow the car to oscillate up and down a little bit without uh, oscillating up and down for an infinite amount of time, and to, as quickly as possible, get the car back to stability, to a stable path. You don't want to oscillate up and down too much. You don't want to oscillate up and down too little. It's about balance. And so what we say in physics is that there are three ways that an object can oscillate. And those three ways are, and I'll use three different colors here to describe them. There is some energy. This is the path of oscillation. And there's something that looks like this. There is something that looks like this. And then there is a path maybe that looks like this. So the red path is what we call an underdamped system. Underdamped. An underdamped system oscillates on for a very long time, and there is no dissipation of the energy, or very little. There's no such thing as no dissipation of energy, but there is very little. And so it vibrates for a very, very long time. The second line, the purple line, is what we call a critically damped system. And in fact, a critically damped system may not even oscillate one time. It may actually come down. I'll use this black line and go right onto back to its original shape, nice and gradual. So that is called a critically damped system. The purple line is a damp system that probably is more like along the line of your car. It's not ideal, but it's pretty close. The black line is going to be more of what a critically damped system looks like, in that we don't have any oscillation, but it does return back to its origin point. The last system is an overdamped system, overdamped. And in an overdamped system, what we have happen is we have the system oscillate, and it doesn't even return back to the equilibrium. So it just starts to oscillate. For example, your car goes over the pothole, the axles go down, but then your car doesn't return back to its original height. It stays elongated or something like that. The overdamped system pulls energy out too fast and doesn't allow the object to return to its original position. One of the easiest ways to think about this is a typical spring. We have our spring, and it is sitting here with a mass on it, and I pull it down, and imagine that when it is released, it does not return back to its original height. This was the original height, and then it returns back. This is the final. After it was sitting in equilibrium, everything was balanced, gravity was pulling down, the spring was pulling up, and then you pull it down, and when you let it go, it returns back only to this point. That's overdamped. Now, we're not talking about elongating or deforming the spring. What we're talking about is that the spring absorbs so much energy that it doesn't allow it to even return back to its original position. That's overdamped. The Critically damped, you would pull it down, and when you pull it down, the final position is going to be the same as the original position. And then the underdamped, this thing is going to oscillate for a while and then eventually come to a stop. The underdamped is what we saw when we were in our lab doing our spring activity earlier this year. If you have any questions, don't hesitate to ask.